We have restored and repaired a decent pile of Model 70s in previous videos, but there are actually a few more to do. So in this video we are going to restore another one and repair a machine that we have previously restored. Okay, let's start with this one here. This machine came untested and it's clearly unrestored. This is really hard to get on camera because the camera tends to overexpose beige boxes. This machine is really grimy. I'm gonna have to do a lot of washing and scrubbing off camera today. Unfortunately, the previous owner kept whatever card was installed here. So let's get inside by removing these two thumb screws and pull that cover off to reveal whatever this IBM has in store for us today. Oh, that doesn't look too bad. This machine looks pretty complete and relatively clean inside. So we've got an 80 meg hard drive. Well, that's a first for me. I've only seen 30, 60 and 120 in these machines before. And we've got a diskette drive. And luckily the battery has been removed, so no battery leakage. And it's getting better. We've got an ASTEC power supply. We are going to repair at least one power supply in this video. And I'll just say, it's not an ASTEC. The sticky gunk too isn't too bad in this machine. There's one large piece here, and just this one piece left in the case here. If you're new to PS2 machines, that sticky gunk is the worst part of restoring an IBM PS2. It has a slightly different diskette drive than what we have seen in previous Model 70 restorations. It's a much thinner drive with a PCB on top. Not sure if we have restored one of these on the channel yet. We also have some RAM installed on this board. We'll check how much in a minute. This looks to be a Type 2 board. You can tell because the Type 1 board goes all the way to the front. It's almost twice the size. And the Type 3 machine has a second board that you can clearly see through this hole here. So definitely a Type 2 machine. Everything in these machines is toolless, except for the motherboard and the power supply. So by pulling on this tab here, we can pull that drive out. We're gonna have to use some deoxit because it's stuck in the edge connector pretty badly. So these drives are notorious for having leaky caps. I did a quick check and this is no exception. So we're gonna have to restore this drive. The hard drive too is toolless and it's removed by pushing on these two tabs. And at the same time pushing the drive back. We can now remove it. I checked these caps and they are of course leaking too. So we'll see if we can save this drive in a minute. Next we can remove the riser that connects to the diskette drive and the spare drive if you have a drive B, and then the hard drive at the back. As you can see, there is no controller here, and that is because it's built in on this PCB. So the hard drive is really thick and large and contains the controller too. The drive cage is then removed by pulling on these white tabs. There is supposed to be a tool included, but this machine is missing one. They are unfortunately quite often missing. But it's not a huge issue. You can use a soft prying tool like this, and it works just as fine. It actually works even better. With all those tabs removed, we can disconnect the speaker and the battery. And then just pull the entire drive cage out. One very common fault with these machines are broken off plastic rivets. This one isn't too bad. Actually, only one is broken, so we'll use some printed replacements later. Now our luck continues. We've got 3 RAM sticks in here. And unfortunately, whatever was installed here stayed with the previous owner. The only tools you need to restore a Model 70 is a 1/4 inch nut driver and a security bit for the power supply. The power supply has 1 screw at the front and 2 screws at the back here. The I/O shield is held in place with 3 screws at the back here too. So we might as well just grab them since we are at the back here. Now we can pull the entire power supply off the board. It connects to the motherboard with this edge connector here. This machine looks slightly newer than other Model 70s we have worked on before. Do we have a date here somewhere? Yeah, it is a pretty late machine. So at least the diskette drive is made in week 46 of 1991. We'll check some more dates in a minute. These screws can get pretty badly jammed, so I use a pretty large nut driver. And the motherboard is held in place with just 3 screws. Yeah, this isn't too bad. The machine is relatively clean inside. And these machines have a 386DX running at 20 MHz. I'm going to remove the EEPROM or the BIOS before the wash, because it has a paper sticker. And paper stickers don't like water. And the sticker on this chip, by the way, also confirms very late 1991. I'm going to check these part numbers in a minute and see what size these are. I removed the speaker since we can't wash it. And it has an even later date, week 9 of 1992. This diskette drive, however, I think will be more than happy to take a nice bath in warm soapy water, because the electrolyte that has leaked out from those caps is very corrosive and will destroy the PCB unless we wash that PCB. Nice dust bunnies inside here. I think this drive is really going to enjoy a bath. So we've got 5 caps on this PCB and most likely a few more underneath this PCB. There are many different brands of IBM PS2 drives and they are all slightly different. This one apparently is made by Alps. Model number TFP723D12F. Older PS2 drives are about twice the size of this one. That's why it has the edge connector on a separate PCB on top of the drive. These drives used to be about this height, so this edge connector was roughly in the middle of the drive. Now that I think of it, I think we may have restored one of these on the channel before. Yeah, I think that's enough to pull the lid off. Oh wow, yeah, this drive definitely needs some cleaning. Check out these guys, absolutely disgusting. Inside here we have a flat flex for the heads, one ribbon cable for the zero track sensor, and one regular JST for the stepper motor back here. So now we can flip that PCB over and see how bad this is. Yeah, I've definitely seen worse. This is not too bad. There is definitely corrosion on some of these pads, but I can't see any damage to the PCB. So I consider this one a pretty good drive. Very restorable. To make the recap later easier, I'm gonna remove this PCB too. Now let's remove the sled from the hard drive so we can have a better look at the PCB underneath here. It didn't look too bad from what I can see, but we won't know until this PCB is off. Oh, I almost forgot. You also need a tiny T8 if you're restoring the hard drive too. And you definitely should. I have yet to see one of these drives without leaky caps. To remove the PCB from the drive, we need to disconnect a flat flex at the back of the drive here. And then tilt the board up so we can get access to the second flat flex on the side here. Well, that is a very dusty PCB. The caps are definitely leaking. But again, I can't see any damage to the board. Just crusty solder. So this is looking pretty good. Next we need to remove some T15 security screws from the power supply. And my usual disclaimer, please don't mess around inside power supplies. Some of the caps inside here could be charged with mains voltage. So we have restored quite a few machines with these AMTECH power supplies. And they have actually all been good so far. So AMTECH did a pretty good job making these. With all the security screws off, we need to pry the power supply apart. Right here in the middle. Okay, more dusts. And a nice brushless panel flow. Only good stuff in here. Yeah, sure enough. Aside from all this dust here, we've got some Rubicon and Nippon Chemicons. They too go bad, of course, but there are definitely worse. And these safety caps are not refus. So after the wash, this power supply should be good to test. There is no need to completely remove the PCB for the wash, but I will at least remove all the screws so I can get all that nasty dust out from underneath. I almost forgot. The nuts holding this transistor here also holds the PCB down, so it needs to be removed. Then we may have to remember to reapply some thermal pastes underneath, after the wash of course. It's a thermal pad and thermal grease. Yeah, definitely needs some cleaning underneath the PCB. That is disgusting. And now it's the next day, so all the parts are clean and dry. Let's start fixing stuff. So the controller on this 80 meg drive is actually quite different from the controllers on the 3060 and 120 meg drives. Among other things, it has a small plastic component squeezed in between these two caps. So we definitely can't use the rework station on this board. But luckily we now have desoldering tweezers, so this shouldn't be a problem. The solder on these caps is quite heavily corroded, so I'm going to use some flux before we remove them. These caps are actually bulging underneath, so they are actually already trying to escape the board. That's the first. So let's try with 400C and see if it's enough for this board. The value on these caps is the same as on other boards we have fixed. These two are 47 micro 16 volts, and this one is a 100 micro 6 volt cap. Yeah, 400C was definitely enough for this small board. It's really tight. I'm gonna have to be careful so I don't melt the plastic components. Yeah, no problems. So how about this last one? Yeah, so easy with these tweezers. Let's add some more flux and remove the old solder with wick. Right, extra component is marked F1, so I'm gonna guess it's a fuse. Yeah, that solder came off pretty easily. Let's clean up that flux. Yeah, these pads are nice and shiny. No damage to this PCB whatsoever. I may actually have to change tip, because those pads are so close to this fuse here. Yeah, we definitely need a really small tip here. Let's try with a large hooked tip. Yeah, I think there's room enough for it. Yeah, it was small enough. If you don't have a small enough tip, you could remove this fuse and then put it back on later. These two are slightly smaller, so they should be easier. The date codes on the chips on this board are from late 91 and early 92. So this is probably the original drive. Yeah, that's plenty of space for this tip. The diskette drive requires a little bit more work, but I wouldn't say it's difficult. So first we have these three guys here, and they are 4.7 16 volt bipolar caps. Now let's see if there's room enough here to use the desoldering tweezers. Yeah, at least this one was really easy. We can't use a rework station here, because this motor here probably doesn't like all that heat. Yeah, that one was easy too. Wow, that popped quite violently in my face. So that was the third time I blew up a cap with these tweezers. So you better use some eye protection if you remove SMD caps with tweezers. And that one was easy too. This has quickly become one of my favorite tools. It's saving me so much time. I'm running at 400C, so maybe I should use a lower temperature. Enough of drama. Let's clean up this flux here. I'll add fresh flux. I think we better stay with this thin tip, because one of the pads on one of the caps is going to be a bit tricky to reach. Let's clean again. Yeah, this hook tip here is absolutely awesome in tight spots like this. Okay, these guys are done. Now let's take care of these two. Okay, I had to find a similar drive and check, because the value is unreadable on this cap here. I lowered the temperature on the tweezers to 360. Let's see if this is enough. And hopefully these caps won't explode in my face. It will of course take a little bit longer. Wow, this guy was really stubborn. But those pads are quite heavily corroded. And there it popped. So 360 wasn't ideal. Let's try 380. Yeah, that was a lot more efficient. It came off after about 4 or 5 seconds without exploding. Okay, same procedure here. Fresh flux and wick. Yeah, these pads look good too. There is some mild corrosion on the solder joints, but I can't see any damage to the PCB. Let's check underneath that flux and make sure. Yeah, this board looks totally fine. Okay, so this guy here is a 4.7 25 volt cap. So this hooked thin tip takes forever to heat up the pad. So it does require some patience. And apparently this guy here is a 10 microfarad 16 volt cap. Okay, this board is done. But we have a second PCB in these drives. These are all 10 microfarad 16 volt caps, all 5 of them. But before we can remove them, we need to remove this resistor here, because we can't reach 2 of the pads. Okay, with this guy out of the way, we can now reach these 2 pads too. And it's the same procedure. Let's go for 380 on this board too. There's always a learning curve. Trying out a new tool. Yeah, that came off really quickly. Yeah, this one too. Wow, I love this tool. 3 seconds. 380. At least on these boards. And the last cap down on this edge. Yeah. Just a few seconds and it's off the board. Now this could be a bit confusing. So these electrolytic caps here are marked with the actual value, 1016. But if we take a look at my new caps here, they are marked 100 and 016. So I'm not sure why they decided to use coded numbers. But on the old cap here, 10 just means 10 microfarad. But on this new cap here, the first 2 digits is 10 and the last 0 just means multiplier of 1. So basically 10 microfarads times 1. This could be a bit confusing if you're not aware of this. And if you're unsure, you can check the data sheet if you can find it, or just measure the cap. So this old cap here is 6.8. So definitely a 10 microfarad cap. And the brand new cap here, marked 100, is 10 microfarad too. Finding datasheets for electrolytic SMD caps isn't always easy, because they're not marked as clearly as larger caps. So measuring it might be your only option. And when measuring a cap, you need to take into account that it will show 10% off, sometimes 20, and still be within tolerance. I just remembered, we actually still have one of these boards unrepaired, because the legs of this chip here was so badly corroded, one of the legs fell off. Luckily this is a standard chip, so I just went ahead and ordered some from AliExpress, so we can fix that drive too now. And I have swapped back to my normal tip, so we don't have to wait for ages to heat up each pad. Well, I'll skip ahead here, otherwise I'm just going to repeat myself. Okay, this board is done too now. We are almost ready to start testing stuff. And somehow I managed to remember the resistor we removed to access those pads. So I guess I'll put it back on before we continue. Underneath the PCB I found some dried up old heat paste. I managed to get it off with IPA. And then there was this large block on top. Some more heat paste. And then a thermal pad. And then even more heat paste. Aztec really took cooling seriously. This seems kind of over the top. And all that cooling is for this transistor, of course. That goes on top. And then it had 2 washers. And then a nut to hold it down. Okay, time for my favorite part of any restoration. The final assembly with nice and shiny parts. This machine cleaned up really nicely. So let's install that power supply. Better not forget that EEPROM. This board won't do much without the BIOS. These RAM sticks were all 2 meg, 85 nanosecond parity. So this should give us 6 megs. Next we have the issue of this broken plastic rivet. This is a very common problem with these machines. So let's remove it. But luckily someone made a project to make printable pegs. So I went ahead and ordered some from the sponsor of this video, PCB Way. They're not just making excellent PCBs, as we have seen in many of my videos, but they also print stuff like this. And compared to buying a printer, these are way cheaper. And of course, a big thanks to PCB Way for supporting this channel. And they are very similar to the original part. I'll put something on the screen here so you can find them easily, and then you can just print them, or have PCBWay print them for you if you don't have a printer like me. So now I can just install the new rivet, and then install the drive cage back into the machine. The original peg is still good, so I'm going to reuse it. Locked and ready to take some drives. But first we need to install the riser. I found a matching date on the chassis too. So this seems to be a complete and original machine in excellent condition. Sometimes I get lucky on eBay, and sometimes I get junk. Let's be optimists and install the battery right away. And the last part to go in is our diskette drive with some fresh caps inside. Now let's be really optimistic and insert a ref disk before we flip that switch. Okay, fingers crossed. Let's see if it works or if it needs any repair. Okay, LED lit up, the fan spun up, hard drive spun up too. We're getting beeps. Oh no, nothing on the screen. Oh crap, we're not getting anything on the screen. But it's reading the disk. Oh no, it's another black screen. But the machine is working. I can hear it read from the diskette. But we're not getting any image. So we seem to have messed up graphics. Oh crap. Well, I did a visual inspection, but I can't see anything obviously wrong here. Well, the machine is executing code. So this is definitely something with the video circuitry here. Okay, I went online and those beep codes confirms it too. One long beep and two short beeps indicates that the primary display adapter is bad. Well, the obvious thing to try is to install an XJ2 card. I only have 2 cards, so I had to borrow this one from the Model 80. I always keep borrowing stuff from that machine. So when I actually want to use it, there's always something missing. And I have to go look for it. Okay, let's see what it does. No, same error code. Huh. Well, it's a long shot. But let's pull that RAM and see if it will give us an error in the 200s. Here it goes. And no, unfortunately, if it was the RAM, we would have had an error now. Okay, I'm checking the temperature, but no more clues. Nothing is getting excessively hot. Okay, well, in that case, let's put this project aside for now and see if we have better luck with the other machine. We have restored this IBM in a previous video, but unfortunately the power supply is quite dead. So let's fix it and finish this project. Okay, so we have removed and tested more or less random components from this board, mostly because I wanted to try out a new component tester. But we didn't find a fault, unfortunately. So let's continue and see if we can fix it today instead. I really wish I had reinstalled all the tested components right away, but I didn't. So I guess I'll reinstall them as we go here. Okay, so the rectifying diodes are all tested. They are good. So our first suspect today is C54 here. It's 1 microfarad, 63 volt cap. So I'm basically just going to start at this end here, then move through the entire board until we find a fault. This power supply, by the way, is completely dead. This is an ROE branded general purpose cap, and it's still at 1 micro. ESR is at 2.5, so that should be okay too. So it's a good cap. I'm going to replace all the caps, even if they test good, because I don't quite trust my meters to tell me the whole truth. Next we need to put Q2 back on the board. And then we have a C11 here. It's a Debo branded 470 micro 25 volt cap. RSS series. There's actually some gunk underneath that cap. I was just about to say that Debo caps are usually good. Let's see, well, it doesn't come off with a dry Q-tip, so that's probably just flux. If it was electrolyte, it would have most likely come off with a dry Q-tip. Not always, but in most cases. Okay, let's see what this guy measures. Oh, nothing! Actually, let me double check. Yeah, we just got lucky. That is one dead cap. Wow, that was quick. Second component we tested, and we have already found a fault in this power supply. Wow, this is one lucky IBM. The delivery guy just stopped by with these like 3 hours ago. So apparently this repair was meant to be. Just to check my meters. This is what we should see on that dead Dabo cap. About 470 micro. So I guess this gunk here is dried up electrolyte after all. Not old flux. And there is actually some more of that gunk underneath the cap. So most likely electrolyte. Some of the transistors that we have removed and tested, they had some dried up heat paste. So I'm going to reapply some fresh heat paste before I reinstall them. Like so. And then reinstall the clamp that pushes them against the heatsink. Okay, I skipped a few caps here. And we are at C22. It's a black Dabo cap too. And it has some gunk underneath. At least partially coming off with a dry Q-tip. And underneath the cap too, there is some kind of yellow gunk. So it's quite clear what happened here. These black Dabo caps have leaked. Okay, all the caps in this power supply are now happy. And all the components we removed in the previous video, they are now back on the PCB. I'm not going to put the rivets back on quite yet. Not until the power supply is tested. Some sticky tape should be good enough for a few minutes. I think we have tested this board in a previous video. So it was just a bad power supply. Now let's see if it still is after we have replaced that leaky cap. Okay, fingers crossed. Okay, the LED lit up and the fan spun up and it's counting up the RAM. Awesome. So another Model 70 saved. And now that it's tested, we can install the rivets. So now I only need to remember where I have misplaced the remaining parts for this project. Well, I found a drive cage. I guess that's a good start. And strangely enough, all the tabs are still good on this drive cage. Well, unless we replace some of them in the restoration video. Well, I found the riser, but then I actually had to go back and watch the restoration video of this machine because I couldn't find the drives, and apparently that is because this machine came without drives. Well, I have a spare hard drive, so let's use it in this project. Well, this is one lucky machine. Found a spare diskette drive too, and we have already recapped both drives in another video. To get rid of those errors, we need to install the battery. Now we can finally put the lid back on, since the battery has been removed. The CMOS has been cleared, so we need to start with the ref disk. Hard drive spun up. It's counting up the RAM. It's seeking from the diskette. And apparently something isn't quite right. But this drive is tested, so I'll try with a different diskette. Okay, fresh copy of the ref disk. Let's try again. It seeks from the disk. And it reads. Okay, totally working machine. Okay, automatic configuration is being run. Automatic configuration complete. But we need to use a reference disk for one more boot before all the settings are done. So now we need to go to set features, time and date, and set a random date, exit and reboot. Now we're done with the ref disk. This machine actually turned out pretty nice. It has a few tiny scuffs, so it's not perfect. Yeah, now I remember, we have tested this drive in another video. It has a messed up antivirus software installed. I think we used it in another machine, but then I ended up installing something else in that machine. But it should be a pretty good match for this Type 1 machine. So I think it gets to stay in here. Okay, so let's say this machine is done. One more Model 70 repaired, and one more restored machine to repair. It's been a few years since we repaired the video circuitry on a PS2 motherboard, so I'm actually looking forward to this repair. But I think this is it for now, so I'll see you guys again next week.